Okay, let's get into our second major topic for this semester in Stage 1 Chemistry, and that's looking at chemical reactions. Now, as part of this topic, we are going to look at some chemical reactions. We are also going to look at writing chemical equations and practice that some more. You've probably have already done some writing chemical equations in earlier years in science. And we're also, around the idea of chemical equations, going to get into some of the maths that underlies chemistry and in particular chemical reactions. And that all, or most of that, revolves around the concept of a mole or the concept of moles. So in this first part, we are going to look at the concept of the mole, and then part B of this subtopic, we will look at doing some calculations involving moles, which is what you'll need to be able to do. Let's get into it. So, 1 mole is equal to 6.02 times 10 to the 23 particles. That is 602 with a lot of zeros after it, which basically means that's a really, really big number. The reason that I guess is such a big number is because atoms are really, really, really small. So when we're dealing with the amount of atoms that might be happening in a reaction, we are dealing with really, really large numbers of atoms. And it is not practical to always be using such large numbers. So we define this concept of a mole, which says that if you have 1 mole of particles, you have 6.02 times 10 to the 23 particles. I'll briefly talk about where that number comes from later. But don't get too hung up on that. It's similar to saying we don't tend to say we've got 12 eggs, we say we've got 1 dozen eggs. We don't say we've got 24 eggs, we've got 2 dozen eggs. So instead of using the exact number of eggs to describe how many eggs we've got, we use dozens of eggs. And we do a similar thing with atoms, molecules and compounds, so all these small particles, but we use the concept of a mole. Just makes it more practical. I'll direct you to have a look at this video here, which just gives you a little bit of context to what a mole is and how you can picture it. And it also, just describes some of the history about how this came about, which fits in really well with the science as a human endeavour. So, hopefully you've got an idea that a mole is just a way of describing a very large number of particles. Now, the next thing we need to understand is relative atomic mass. Now, I'll apologise in advance, but only partially, because this is terminology that gets used and it can be a bit confusing to start with, but it's not maybe as confusing as it seems. We use the term relative atomic mass, but sometimes we use atomic weight instead, but it means the same thing. Or sometimes we use average atomic mass, but it means the same thing. Or sometimes we use formula mass or relative formula mass or average formula mass. It means the same thing as relative atomic mass. I tend to often use the term molar mass. It means the same thing as relative atomic mass. So all of these terms here get used interchangeably, and all of them are used to describe the mass of 1 mole of atoms of an element, or a molecule or a compound, or it could be as well. So if we are dealing with carbon, when we look at the periodic table, so I've just got a part of the periodic table here, you can see here this number 12.01 is underneath the element, and each element has a number like that under it. I think if you look at hydrogens, it's 1.008 or something like that. What that is telling us, that number there, is that 1 mole of carbon atoms has a mass of 12.01 grams. So, whenever you see that number in the periodic table underneath an element, it is telling you what is the mass of 1 mole of that atom. So in this case, 1 mole of carbon atoms has a mass of 12.0 grams. If I was going to say, as I said before briefly, the reason the mole is equal to this number here is actually because if you have exactly 1 mole of carbon-12 atoms, and I'll talk about the difference between naturally occurring carbon and carbon-12 atoms in a sec, it would weigh exactly 12 grams. That's actually how they define the mole. You don't really need to know that, but it's just some interesting background. So, relative atomic mass, or molar mass, or whatever we want to call it, is similar to the mass number. So if you remember, in the first topic, we looked at things like mass number of elements, and we would have talked about carbon-12 and carbon-13, where carbon-12 has 6 protons and 6 neutrons, so that gives you a mass number of 12. Carbon-13 has 6 protons and 7 neutrons, giving you a mass number of 13. So when we talk about average atomic mass, it's similar to that, but it's slightly different because naturally occurring elements contain a mixture of isotopes. E.g., naturally occurring carbon contains about 99% carbon-12 and about 1% carbon-13. Hence, the relative atomic mass, so where we get here to the relative atomic mass, or the average atomic mass, is 12.01, not exactly 12. If it was all carbon-12, that mass number would be 12.0000. But because there's a small amount of carbon-13 if you have a sample, if you had 100 carbon atoms, there would be 99 carbon-12s there, but there'd be 1 carbon-13 there. So that just sort of lifts up the average, and that means that the mass is slightly greater than 12. This bit here can be a little bit confusing. There is some questions on it, and it's good to try and understand it, but this is one of those things, if you don't quite get this, it's not really going to affect your understanding of other things going forward. You do need to understand what a mole is, and how we use moles, and the other stuff we're going to go on to, but don't get too hung up on relative atomic mass. I think I say this here. I've put a link to a video here that goes through in a little bit more detail determining relative atomic masses or average atomic masses or molecular masses, and also, and we may have used this before already, I can't remember, also to a simulation where you can work out average atomic masses and see how that works on PhET. So if you're struggling with this concept, I'd encourage you to go and have a look, particularly when we get to those questions. But as I said, you need to understand most of this stuff about moles, but it's for everything else to make sense. But if you don't understand this relative atomic mass, you just read them off the periodic table when you need them. It's not going to hold you back too much. Let's keep moving.